All right, so how can that get tougher? Well, maybe you have stuff to factor on both sides of the fraction bar. So I'm going to do the top part in the color black. So that's a trinomial with the leading coefficient of 1. We're looking for ways to multiply to negative 18 and add to negative 3. Negative 18, add to negative 3. If it helps to make your list of factors of 18, do it. Now, one of them needs to be negative. One of the left column or the right column has to have a number that's negative to multiply to a negative 18. So it'd need to be negative 6 because that adds to negative 3 once we add negative 6 and positive 3. Yeah, it multiplies to negative 18. So the top can be factored to, give myself a lot of space here, x plus 3, the 3 is positive, times x minus 6. The 6 is negative. Now on the bottom, that's not a trinomial. It's not a difference of squares, but I can see that I can factor out a 2x from each of those two terms. It has a GCF. Always look for a GCF. Always. You'll see that in the next set as well, how important that is. So then we're left with x plus 3. Maybe redistribute that in your mind. Make sure it equates. Yes, it does. All right, so do we have any common factors on the top and the bottom that we can eliminate? Yes. X plus 3, x plus 3. Really, this is just equivalent to x minus 6 divided by 2x. Now, before you work on the direction, say simplify each, which we just did, although we should clean that answer up, and state the excluded values. One excluded value is going to be 0. X can't equal 0 because that makes this factor equal 0, which makes the bottom equal 0. And then negative 3 makes the other factor equal 0, which when they multiply it together makes everything equal 0 on the bottom. We can't have that. So that's why they have the excluded values here. We're doing a little more practice with that on this set. Where to go to next? How about 32? So 32, we can factor the top into 6 times n minus 10. On the bottom, it's a trinomial. A is equal to 1. That's good. There is no GCF. We're looking for numbers that multiply to 50 and add to negative 15. Sometimes these get people a little stuck because it's multiplying to a positive number, positive 50. Either both numbers need to be positive or both need to be negative, like both numbers in each column, or the numbers in each column. So it's going to look like this because we're trying to add to a negative 15. So negative 5 and negative 10 multiply to positive 50 and add to negative 15. So we can factor this trinomial as x minus 5 times, I switched it to x, it's an n minus 5 times n minus 10. And hooray, we do have a common factor. They're fun to eliminate or cancel out. So, zoop, shoop. Now, you can't make it up. Sometimes there aren't going to be common factors, so it's just, you're done, basically. So we get 6 over n minus 5, and that's our simplified version, our simplified answer, and n can't be positive 5. N can't equal 5, and n can't equal 10. Because those numbers would send the bottom to 0. If you plug in 5 or 10 right here, your calculator will spit out a 0. You can't have divided by 0. All right, so can it get any more difficult? Yes, but, oh yeah. So here we're, looks like on these, we have a trinomial for the top and the bottom. So on the top, we're trying to multiply to 1 and add to negative 2. List your ways to multiply to 1. It's just 1 times 1. Since it's a positive 1, either both 1s are positive or both 1s are negative. It'd be this option right here. So this factors to a minus 1 times a minus 1. Now I'm not going to write a minus 1 squared, which is a more concise and typically better way to write this. I want to see all the factors so I can know if there's some that I can cancel out. On the bottom, trying to multiply to negative 6 and add to 5. Again, notice our leading coefficient on these are 1. That's good. You always want that. So here it'd be negative, just kidding, not negative, negative 6 and positive 1 would do it actually, right? Oh, positive 6, negative 1. Just kidding. Double check that. Multiplies to negative 6 and adds to positive 5. We're good. A plus 6, A minus 1. And so this A minus 1, a factor of the bottom, will eliminate one of the factors on top. So we're left with A minus 1 over A plus 6. I don't know if we're supposed to state the invalid numbers, the numbers that make the bottom equal 0 would be negative 6 and positive 1, if we're supposed to. So there's our simplified answer and the values that can't be in our domain. Let's go to the next way that they're going to make this a little more difficult. So, number 51. Oh man, if you remember factoring when your leading coefficient's greater than 1, it can be some work. However, the nice thing about this is, isn't there a GCF? On the top, doesn't 18 go into all of those terms? Yes. 18 times n squared plus n minus 2. That's equivalent to the original trinomial. And on the bottom, we can factor a 27 out of each of these. So then we get n squared plus n minus 2. What's funny here, folks, and this won't happen very often, but holy cow, these trinomials right here are exactly the same. They are a common factor. So we don't have to worry about actually factoring those trinomials into binomials or multiples of binomials. And then, folks, this 18 over 27 equals 2/3. So that's actually the best answer. Number 52. On the top, the leading coefficient is not 1. And that'll happen sometimes, but we can factor that 2 out. Oh, come on. There we go. I can factor the 2 out to get n squared minus 10n plus 16. And on the bottom, I just have 8 times n minus 8. But we want to factor as far as you can. This top part, I can still factor, even though I already factored out a GCF. But now, I'm factoring a trinomial with a leading coefficient of 1. So I'm looking for ways to multiply to 16 and add to negative 10. So let's see here. Either both numbers have to be positive or both numbers need to be negative because we're multiplying to a positive and a negative times a negative is a positive. So because we're adding then to a negative 10, both have to be negative. It's negative 2 and negative 8. So this common factor here gets eliminated. And then the other thing is this 2/8 out in front can get simplified to 1/4. Oh, that's weird. Weird how I spaced that out. And then really, that 1 is not necessary to write down. So this is the best answer, folks. I'll do one more of them. Actually, let's see here. Do we have... Excuse my clicking. I'm going to do one more, and then I'm going to stop this video and make a new one, because the last part after this video will be the biggest challenge that there is. So we can factor a 6p out of the top. So we have p plus 10. And on the bottom, we can factor an 8 out of everything. So p squared plus 11p plus 10. And then I'm going to do the work over here. Numbers that multiply to 10 and add to 11. That's 10 and 1. That's kind of a tricky one. Sometimes people don't see that. P plus 10 times P plus 1. On top we have 6P p times p plus 10. So the p plus 10s will cancel out. And on the bottom we have 8 times p plus 1. Of course, on the top we have 6p. That 6/8 can get reduced or simplified to 3/4. There we are.